Now let's talk about how we write a polynomial function from the graph. And these will always say, at least for our purposes right now, use the smallest degree possible. So that means that our only option for multiplicities is either 1 or 2. So first of all, let's list our x-intercepts and their multiplicities. So x-intercepts, multiplicities. We have for our x-intercepts -3, -1, and +2. So -3, -1, and +2. And I'm sorry, let's write whether they touch or cross and then do the multiplicities. Touch or cross and then do the multiplicities. So at -3, the graph crosses the x-axis. At -1, it touches. And at 2, it crosses. Remember, anytime it crosses, it has odd multiplicity. And since our multiplicities can only be 1 or 2 in this instance, because it says use the smallest degree possible, that means if it crosses, the multiplicity is 1, and if it touches, the multiplicity is 2. Now we can use that information to write our function. So our function is f of x equals a, and we'll talk about a in just a minute. That's just going to be a vertical stretch or compression, and we're going to have to figure that out. So it's going to be a, and then remember it's always, each of our factors is x minus our x-intercept. So x minus a -3 is x plus 3. X minus a -1 is x plus 1. And x minus a +2 is x minus 2. Now we have to go back and do our multiplicities. So a multiplicity of 1 means an exponent of 1, we don't have to write it. But we do have to write the multiplicity of 2. How are we going to figure out what that a is? Well, the easiest thing to do is to take any point as long as it's not an x-intercept, but any other point, and then solve for a. So let's look at our graph here. We have what I would consider 3 decent candidates for plugging in. We can clearly see that right here we have the point -2, -2. Sorry, let me write that a little bit better. So this point is -2, -2. We also can see that we have the point 0, -3. And we also have this point down here, which I think is 1, -8. It doesn't matter which one you pick. using any of them should give you the exact same value for a. I'm going to pick the 0, -3 because that's going to make the arithmetic easier. So I will say f of 0, that is my y. So -3 equals a times 0 plus 3, 0 plus 1 squared times 0 minus 2. And now I will just solve. So I have 3 times 1 times a -2. It looks like I have -3 equals -6a. Divide both sides by -6. And we get a equals a positive 1/2. So our function is f of x equals 1/2, plug a, the number, back in, and then just tack on all our factors with their appropriate exponents based on the multiplicity. So this is our final answer for finding the function of the smallest possible degree that will give us that graph. So pause the video here. You guys try this second one and then restart the video and see if you got it right. So I'm going to assume you've already tried this. So again, let's list our x-intercepts, the touching or crossing, and then what that means for the multiplicity. So if we look at our x-intercepts on the graph, we have 2. We have x equals 0 and we have x equals 1. The graph crosses at 0, so that means a multiplicity of 1. It only touches the x-axis at 1, which means that's a multiplicity of 2. So our function looks like some constant that we'll have to find times x minus 0 with a multiplicity of 1 times x minus 1 with a multiplicity of 2. So let's simplify this just a little bit. We don't need to write x minus 0 because that's really just x. So we have a times x minus 1 squared. Now we need to find a by plugging in a point. And if you notice, they've conveniently given us a point on the graph. It is 2, -4. So we will plug in -4 for y, or f of x, since they're the same thing. And we'll plug 2 in for x. So we have a times 2 times the quantity 2 minus 1 squared. So proceeding to solve for a, we have 2 times 1 squared is just 2. So if we divide both sides by 2, we end up with a is -2. So now we just plug that back in for a in our function. So we have -2 times x minus 1 whole thing squared. And that's all there is to graphing these. Getting the equations from the graph. In the next video, which will be the last one for section 5.1, we will essentially do the same things here, but we'll be graphing instead. So they're going to give us an equation, and we're going to create the graph.